Okay, let's continue the section 2.2. We already, in the second part, we already introduced the intercepts and XY intercepts. Okay, so intercepts, X intercepts, Y intercepts. So intercepts, just intercept, it's a point. Okay, so you see, this is one intercept, second, third, and fourth. So when you talk about intercept, it should be like intercept -3, 0. This is intercept, -1, 0, and 2.5, 0, 2.5, 0, 2.5. This is a y intercept on the y-axis, and here possibly like 3, 0. So the intercept points, it contains x and y coordinates. And the x-intercepts are the x coordinate of the intercepts with on the x-axis. So x-intercept will be -3, -1, and 3. They are numbers. X-intercepts are numbers, intercepts a point. Y-intercepts are the y-coordinate of the intercepts on the y-axis. So here's 2.5. This number 2.5 comes from this y-intercept. Okay, comes from the intercept on the y-axis. So this is also number. All right. So this is the intercepts from a graph, the second part. And third part, we're going to find intercepts from an equation. How do we do that? We're going to find x-intercepts and y-intercept because the intercepts are mainly determined either by x-intercept or by y-intercept. Once you can determine those two numbers, you just add a proper 0. For example, for the x-intercept, you just put y-coordinate 0. For the y-intercept, you just put x-coordinate 0. You can recover all the intercepts. So the important thing is to find x and y intercepts. So the procedure to find y-intercepts, let x be 0 in the equation. Find y-intercept, x should be 0. X is 0 in the equation. Solve for y. Parallelly, to find x-intercepts, let y be 0. You see, x-intercept, y is always 0 in the equation. Solve for x. All right, so that's the procedure, abstract one. Okay, now let's see the example. Let's see how do we solve problems. Find the x, y intercepts of the graph of the equation y equal to x squared minus 4. Okay, So we're going to find the x, y intercepts of the graph of y equal to x squared minus 4. All right, so to find x intercepts y equal to 0, x intercept y is 0, y is 0. Well, see, this is the equation. Y is 0, so you get 0 equal to x squared minus 4. So you get x squared is equal to 4, then x is plus or minus 2. So there are two solutions. X squared equal to 4, x is plus or minus 2. So there are two x intercepts. Okay, so to find the y intercept, you let x be 0. Y intercept, x is nothing, right? So x is 0, so you get a y equal to 0 squared minus 4. Y is equal to negative 4. You don't do any further complex computation, just directly get a y equal to negative 4. So you can just answer the question. So the x intercepts are 2 and negative 2. Y intercept is negative 4, period. That's it. See it? So to find x intercept, y is 0. Y intercept, x is 0. Okay? Very good. So that's not a very difficult procedure. Just solve for either x or solve for y. Okay, so that's part 3. Find intercepts from equation. This is our topic, part 3. And let's see if we have more example from the exercise. All right, let's see the exercise. Similar question. Find x, y intercept. Find x, y intercepts of the graph of, this is a problem 28 on page 165. 4x squared plus y is equal to 0. All right, so let's check. X intercepts. X intercept, y is 0. Y equal to 0. So it's get 4x squared plus 0 equal to 4. So 4x squared is equal to 4. Then we divide the equation by 4. We get x squared is equal to 1. So x is plus or minus 1. Two answers, plus or minus 1. Y intercept, x is 0. X is 0. So 4 times 0 squared is 0. So we just get y equal to 4. So very simple. So the x intercept plus or minus 1, 2 into x intercept. Y intercept, 4. That's it. That is it. Okay, so I believe the procedure is clear enough. Now let's move to the next part of the section. This section is very long. Let's move to the next part. Next part, we're going to test the equation for symmetry. Okay. Test an equation for symmetry with respect to the x-axis, y-axis, and the origin. Okay. So how do we test this stuff? Before we do that, let's first look at the symmetric points. Okay, so now assume we have a point in x in the first quadrant. We have a point in the first quadrant here. It means this is x. This is y. Then if we're talking about a symmetric point with respect to the y-axis, okay, so you're going to get the image possibly here. It is on the same level, so the y-coordinate is still y, but this part is x, then this part will be negative x, right? You have a 1, have a negative 1. So this is a negative x. So the symmetric point with respect to y-axis is negative x, y, has a coordinate negative x or y. The original point has coordinate x or y. You flip it to the left side, you get a negative y. It is on the same level, so you still have negative. You still have the same y. Okay, so it's a symmetric with respect to the y-axis. So symmetric point with respect to the y-axis. Okay, symmetric point with respect to the y-axis. It has a coordinate negative x or y for the original point x, y. Now, if we're talking about a symmetric point with respect to x-axis, you see here, it's like this. You see, it's on the same, it has the same projection at this x point, so the x coordinate is still x, but you flip it from top to the bottom, it becomes negative y, right? Okay, so this is symmetric point with respect to the x-axis. With respect to y-axis, y does not change. With respect to x-axis, x does not change. You change the other one. Okay? And what is symmetric point with respect to the origin? You see, you're going to change x and change y, both. All right? You're going to change x, change y. You really cross the origin, right? So x becomes negative x, y becomes negative y. So this is a symmetric point with respect to the origin. A symmetric point with respect to the origin. All right? So this is the basic information. The basic information. Okay, so keep this in mind. You have to keep something in mind. Keep this in mind. Let's try to define the following stuff. So the definition. A graph is said to be symmetric with respect to the x-axis. If it is symmetric with respect to the x-axis, means this point is on the graph, then its corresponding symmetric point with respect to x-axis is also on the graph. So this if for every point x, y on the graph, the point x negative y, this part is also on the graph. This point is also on the graph. Okay, so that's the definition, what is the meaning of a symmetric with respect to the x-axis. xy on the graph, x negative y is also on the graph. How do we know the point is on the graph? i.e., this symbol x negative y satisfies the equation. Okay? If x, y satisfy the equation. All right? So this is what we mean symmetric with respect to x-axis. Let's see the example. Okay? So, for example, if I have x squared plus y squared equal to 25. And we know 3, 4 is on the graph. Because 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So this pair of coordinates satisfy the equation. So 3, 4 is on the graph. And 3, negative 4, you see, this is x, y. Then this is x, and this becomes negative y. X, negative y is also on the graph. How do we know it is also on the graph? We just check. 3 squared is 9. Negative 4 squared is also 16. 9 plus 16 is 25. Okay? So that means this symmetric pair both on the graph. Symmetric pair both on the graph. Then it says for every point, whenever you have a point, you must get the corresponding point also on the graph. Then we can say it is symmetric with respect to x-axis. It does not say we just pick up one sample and test it. It's just it's not the proof. It's just like the demonstration. Okay, example. It's example. Okay. So this is a symmetric point with respect to x-axis. If this point, this is a symmetric point with respect to x-axis. If this point is on the graph. Similarly, if this point is on the graph, we will say the graph is symmetric with respect to y-axis. So the similar definition. A graph is said to be symmetric with respect to the y-axis if for every point x, y on the graph, the point, which point? This point. The point negative x and y is also on the graph. Because this is a symmetric point with respect to y-axis, then we say it is you see, it's symmetric with respect to the y-axis. So similarly, for this one, if we pick up the same example, we know 3, 4 is on the graph. We see that we put negative 3 and 4, we need to test. We need to really verify. Negative 3 squared is 9, 4 squared 16, 9 plus 16 is 25. It is also on the graph. This one is just like supporting evidence for the graph of this equation symmetric about the y-axis. It's not a proof, it's just supporting evidence. Okay, so this one is also symmetric with respect to y-axis. Okay, so choose this point, it's a symmetric with respect to x-axis. Choose this point, it's symmetric with respect to y-axis. What happens if we choose this one? We will call the graph is symmetric with respect to the origin. Okay, a graph is said to be symmetric with respect to the origin if for every point x, y on the graph, the point negative x and negative y is also on the graph. Then if this condition is satisfied, we say the graph is symmetric with respect to the origin. And of course, we can pick up the same example, and we are going to put a -3, -4 this time. We can select the same example because this is a very, very nice shape. It's a circle centered at the origin. All right, so that's a symmetry with respect to the origin. Okay, so we're going to use example to really verify, not just supporting evidence, not just check some point. We're going to verify it really satisfy the situation, or it is really symmetric with respect to whatever line or origin. Okay, let's see one example. Test y equal to 4x squared over x squared plus 1 for symmetry. Okay, so we don't know anything about this, the symmetry of this of the graph of this equation. We just want to check it, or find it, search for it. Okay, so test for x-axis. Test for x-axis, you're going to change y to be -1. Okay, so to test for symmetry with respect to the x-axis, we replace y by -1. Whenever you see y, you're going to use -1. Okay, so let's check. Here, only here you have a y, so you're going to write -1. Okay, so this equation, well, it's not, we're not solving for equation, we just compare them. They're different. One has negative sign, the other one has no negative sign. And you have no way to eliminate this negative sign. You will see later what I mean eliminate. There's no way you can eliminate this negative sign. So it is not equivalent to y equal to 4x squared over x squared plus 1. They are different. Basically, I'm saying they are different. When you do such replacement, you actually change the equation. Then the graph is not symmetric with respect to the x-axis. Okay, so when this happens, we're going to get it is not symmetric with respect to x-axis. So we finish one part. and we have other two. The other one is y-axis, then the third one will be the origin. Okay, second, to test for symmetry with respect to the y-axis, we replace x by negative x. Remember, we replace x by negative x. Then what we get? We will get y squared. Here it's a 4. You get x squared. Then you replace x by negative x. You will get a negative x squared. X is a one quantity. Now negative x itself is also one quantity. The bottom it is negative x quantity squared. All right, so x, it occupy a position. Now this moment, you fill this position by negative x. Because it has negative sign, you're going to use parentheses to emphasize negative x is one piece. So you're going to get a negative x squared. 4 times negative x squared over negative x squared plus 1. And so far, let's see how do we simplify it. This one, there's no way to simplify, but this one we can, because negative x squared is just x squared. That is the property of the square function. And the negative x squared again is x squared. So this process, we use the property of square function. Here, there's no square function, so there's no way for us to eliminate this negative sign. This part, we can do it because of a square function, because of special property of it. All right? So you see here now, after you replace x by negative x, after you simplify it, you get y is equal to 4x squared over x squared plus 1. It is equivalent to y equal to 4x squared over x squared plus 1. So actually, it's identical to the original equation, right? We just use equivalent. Equivalent means we'll do some process. Okay, it is this one. I mean, it means this one. It is equivalent to the original one. Again, here we do not solve for equations. We do not solve equation. We just barely compare them with simple modification. No solution, just compare. They are same. Okay? Then the graph, because it is equivalent, the graph is symmetric with respect to the y-axis. It's symmetric with respect to the y-axis. We just barely observe if they are the same or not. We do not solve equations. Okay? Okay, so this is a first x-axis, here y-axis, third the origin, to test for symmetry with respect to the origin. Okay, so what do? We replace x by negative x, y by negative y. We replace x by, you see here, x, y is replaced by negative x, negative y. So x becomes negative x, y becomes negative y. Okay, so let's check. Y becomes negative y, so this y becomes negative. So you got the negative y. X becomes negative x, you got the 4 times parenthesis negative x squared over parenthesis negative x squared plus 1. All right, and like the second case, we know we have square function. This square can eliminate negative sign inside it. So it's 4x squared over here is the same thing, x squared plus 1. Remember, once again, we use the property negative x squared is equal to x squared for whatever x. Okay, so see this part is identical to the right side, but this part is negative y. Again, there's no way to cancel this negative sign. This negative sign is cancelled because you have square function, but here there's nothing you can do. So it is not equivalent to the original equation. You barely just compare. Here it's negative y equal to it. This one is a y equal to it. They are really different by phase. Okay? So the graph is not symmetric. With respect to the origin. Is not symmetric with respect to the origin. Okay? Okay, now let's see one more example. Let's see another example. Problem on page 166. Problem 65. Y is equal to x squared minus 3x minus 4. We're going to test for symmetry with respect to x, y axis and the origin. Okay, so to test for symmetry with respect to the x-axis. With respect to x-axis, we replace y by negative y. Okay. To test for x-axis, x does not change. Replace y by negative y, so you will get a negative y equal to x squared minus 3x minus 4. Well, clearly they're different. So it is not equivalent to y equal to x squared minus 3x minus 4. So the graph is not symmetric with respect to the x-axis. Okay? It's not symmetric. Okay, now this is one. And the second one, to test for symmetry, not symmetric, for symmetry with respect to the y-axis. We replace x by negative x by negative x. Okay, now let's see. Here, y is still the same y. Whenever you see x, you're going to write a negative x. Be careful, you need a parenthesis in many cases. So minus 3 times x, it becomes 3 times negative x and minus 4. Okay, now let's do a small simplification. Negative x squared is just x squared. Minus 3 times negative x, negative is plus 3x and minus 4. Well, here you can do simplification. Here you also do simplification, but you check this equation just by face. It's different from the original one. It is different. There's no way you can do it. You can manipulate to get the original equation from here. So it is not, did I say not? Okay, yes. it is not equivalent to y equal to x squared minus 3x minus 4. So the graph is not symmetric with respect to the y-axis. Okay, it's not symmetric. There's no symmetry. 3. To test the symmetry with respect to the origin. To test for the symmetry with respect to the origin, we replace, you see, actually you do the both of a previous step. Replace x by negative x, y by negative y. So y becomes negative y. Because in front of it, there's nothing, so I don't put a parenthesis, but technically, it's better for you to put a parenthesis. Let me do it here. X becomes negative x, parenthesis square, minus 3 times negative x minus 4. Okay, so here, negative x squared is x squared, minus 3 times negative x plus 3x and minus 4. If you want, you can multiply two sides by negative 1. You get a y is equal to negative x squared minus 3x and plus 4. But anyway, this one and this one, just check them part by part. They're different. Here you have negative x squared. Here you have x squared. Here you have negative x. Here's plus 4. Here's minus 4. So it is not equivalent to y equal to x squared minus 3x minus 4. So the graph is not symmetric with respect to the origin. So unfortunately, the graph of this equation is not symmetric, has no any symmetry, has no any symmetry. It's not symmetric about x-axis, not symmetric about y-axis, it's not symmetric about the origin. All right, so what is the geometric meaning about those symmetries? So, for example, if we have y equal to x squared, you can check that this graph, the graph of this equation will be symmetric with respect to the y-axis, because for y-axis, you see, check here, with respect to y-axis, you replace x by negative x, but the negative x squared is equal to x squared. So it is symmetric with respect to y-axis. Geometrically, you can just fold it along y-axis, two pieces of the graph, partial graph, they coincide. So that's what we mean symmetric with respect to y-axis. Y becomes a axis, symmetric axis. Y-axis is the symmetric axis. In this case, you fold two pieces along y-axis. They coincide. And if you have x equal to y squared, you can check it is symmetric with respect to x-axis. It looks like this. So you're going to fold the graph along x-axis. So x-axis is the symmetric axis. Okay. What happens if we have symmetry with respect to the origin? For example, if we have y equal to x cubed, we're going to replace x by negative x, y by negative y. Let's see what's going on. Y becomes negative y, so left side is negative y. X becomes negative x, so it's a negative x cubed. Okay, and then you see this is cubed. You have 3 copies of negative x, negative x, negative x. So you have negative, negative canceled. You still have 1 negative sign. And you have x, it becomes negative x cubed. Okay, whenever you have odd power, 3, 5, 7, 9, 11, you can just move this negative sign forward because you have negative copies of negative sign. They cancel the pairwise and you still have 1. So left hand side is negative 1. And then you multiply these 2 sides by negative 1, you can cancel the negative sign from 2 sides. So you come back with y equal to x cubed. So this one, after replacement, you get the original equation. You get the original equation. Don't solve for equation. There's no solution of equation in this moment. So it means the graph of this function, the graph of this equation is symmetric with respect to the origin. The geometric meaning is that you have this right piece, you're going to fix the origin, rotate 180 degree, you will get the left piece. You see, you rotate 180 degree from here, you rotate 180 degree, you get the other piece. If this happens, that is a symmetry with respect to the origin. Or if you have a point here, you connect it and meet the other point on the other branch, and this point is a midpoint always. Midpoint always. So you change your point here, you try, assume my graph is precise. This pair of a point, this origin is a midpoint. This pair of a point, origin is midpoint. If this condition is satisfied, we can say that the graph is symmetric with respect to the origin. But basically, you just do the rotation 180 degrees. Okay, so this is the part 4, test for symmetry. Test for symmetry. Again, test for symmetry with respect to x-axis, y becomes negative y. Test for symmetry with respect to y-axis, x becomes negative x. Test for symmetry with respect to the origin, x becomes negative x and y becomes negative y. Okay, so that is the basic steps. Okay, so we don't finish this section yet. Let me see what's next. Okay, and we can continue. Next, we're trying to sketch the graph. So far, we can only sketch some simple graphs. Okay, so we'll have several examples to sketch the graph. First example. Graph, this is part 5, how to graph the key equation. We just have some key equation. Graph the equation y equal to x cubed. So first, we actually just verified. We already did something we want to do. We verified that we test for symmetry. We notice that the graph is symmetric with respect to the origin. The graph is going to be symmetric with respect to the origin. Okay, so you're going to do 3 parts. Here we just do 1 part. And second, we know after this step, after this step, we know that, we know it. And then it tells us we only need to sketch the graph of this right branch and rotate 180 degrees, we can get the left branch. So we evaluate. One x is 0, x is 1, x is 2, x is 3. You get a corresponding y equal to 0. 0 cubed is 0. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. 3 cubed is 27. 3 times 3 times 3. After we got them, well, 27 is very big. So let's check it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Impossible. Here's 10. I need 20 and 27. It's huge. It's very far. Anyway, it's some place above. But I know where 8 is. 1 and 2. 3, I don't know. 1, 2. 0 is 0. 1 is 1. 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8 is here. So I'm going to just use almost a straight segment to connect them. Almost, not straight segment, and keep going. Okay, this will be more or less the graph of y equal to x cubed on the positive part. And then you're going to imagine you rotate it 180 degree down, you will get this. So that's exactly the graph. We just check it. Okay, so this problem, you see x cubed. Why we choose cubed? Because when you have a cubed, you will get this negative sign. Go back and remember I mentioned 3, 5, 7, 9, 11, 13, 15. All these we will have this negative sign and cancel with this one. It is symmetric with respect to x origin. So when you have x to 5th power, y equal to x to 5th power, y equal to x to 7th power, y equal to x to 9th power, y equal to x to 11th power, all odd powers. All odd powers, the graph will be always more or less like this. Okay? And all those, the graphs for all these equations will be symmetric with respect to the origin. Okay? And the other one, x equal to y squared. X equal to y squared actually is like this. We also mentioned it before. X equal to y squared. It is symmetric with respect. Well, let's see the graph. We're going to check it is symmetric with respect to x-axis to test for symmetry with respect to the x-axis. We replace y by negative y. So we'll get x equal to negative y squared. Negative y squared is y squared. Right? So you see x is a y squared, x is y squared. So we know the graph is symmetric with respect to the x-axis. Okay? With respect to the x-axis. So it will be more or less like, you are going to choose the top piece and flip it, you will get the bottom piece. So you will choose y equal to 0, y equal to 1, y equal to 2, y equal to 3. You check the corresponding one. So x becomes 0, y squared. X becomes 1, 1 squared. X becomes 4, 2 squared. X is 9, 3 squared. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3. Y is 0, x is 0. Y is 1, x is 1. Y is 2, x is 4. 1, 2, 3, 4. Y 3, x is 9. 1, 2, 3, 4, 5, 6, 8, 9. So you use almost a straight segment to connect them. This is top piece. The graph is symmetric with respect to x-axis, so the bottom piece will be more or less like this. That's something you can imagine. Okay, so this is the symmetric graph with respect to x-axis. And the final one, symmetric point with respect to the origin. Another example, we choose the reciprocal function. Reciprocal function, we're going to replace x by, we test for the symmetry with respect to the origin. We replace x by negative x, y by negative y. You get a negative y is equal to 1 over negative x. And of course, these two negatives are cancelled. You get a y equal to 1 over x. So you get a symmetric point with respect to the origin. Okay? So it's checked. And then it tells us we're going to just draw the piece in the first quadrant and rotate it 180 degrees to get the other piece. So you can choose, at this moment, x cannot be 0. X is 1, x is 2, x is 1 half. Then y becomes 1. 1x is 2, y is 1 half. 1x is 1 half, y is 2. So 1, 2. 1, 2. X is 1, y is 1. X is 2, y is 1 half. X is 1 half, y is 2. So you get this in the first quadrant, and you rotate it 180 degrees, you will get the other part. Okay, that is the graph of the reciprocal functions. All right, so again, all these process looks very simple. Do exercise and try to handle or grab the method. Okay, thank you. We finished this video and we'll continue in the next video.